So far, we've looked at how you can check solutions to an equation to see if they're correct, how you can graph points on a line, and how you can find the other missing variable if you're given a value for one of the variables. And then doing all of those things together. Given one variable, solving for the other, determining a point, and plotting it on a graph. But what do you do if they don't give you either the x or the y? That's what this next section is going to talk about, is that how do we solve for both of these variables? So the first thing to understand is that linear equations have an infinite number of answers. As long as you keep sticking in a new value for x, you'll continue to get a new value for y. Okay? So all of these answers can be expressed as an ordered pair. So while each individual answer could be expressed as an ordered pair, it's not possible to express every answer, since even if you found the values for y when x was 1, 2, 3, 4, and 5, but what about 1 1/2? What about 1 1/10? What about 1 1/100th? It's not possible to name every possible answer they could be. So because of that, answers to linear equations are usually shown on a graph. And the graph that shows this answer, the graph of all linear equations, is a straight line. That's what makes them linear equations, as opposed to the other types of equations that you'll be learning in your next class or the one after it. So, how do we determine those x and y values? Well, one good place to start is by finding what are called the intercepts. So the x-intercept will tell you where the line will cross the x-axis. Okay? And this is at the point where y is equal to 0. So looking back at that last graph that we created, when the y is 0, it's not a positive or a negative, it's right here at 0. Wherever it is that y's value is 0, that's going to be the point where our line is crossing over this x-axis. Likewise, the y-intercept tells you where the line will cross the y-axis. Okay? And that's going to be at the point where the x is equal to 0. So looking back at our graph again, if we want to know where it's going to cross the y-axis, we look for the point where this is 0. So wherever that line occurs, at the point when x is a 0, which is along this y-axis, that's going to be the y-intercept. So let's figure a couple of these out and put them on our graph. The first problem we're looking at is the equation 2x plus y equals 0. So I'm going to start by allowing x to be equal to 0. So this is going to give me the y-intercept. So the equation I'm solving is 2 times 0 plus y equals negative 3. Well, that ends up being 0 plus y is a negative 3. So y is just equal to negative 3, giving me the ordered pair 0, negative 3. Next I'm going to try allowing y to be 0. So when I put that into the equation, I get 2x plus 0 equals negative 3, or 2x equals negative 3. Dividing by 2 gives me x is equal to a negative 3/2. And when you're graphing a line, although 2 points is enough to create a line just by connecting those 2 dots, it's always a good idea to check a third point to make sure that they do in fact connect in a straight line. Because if for some reason they don't, that means there's been an error somewhere in your calculations. So this third point is kind of our insurance policy. And you can choose any value that you want for these. I'm going to choose one that makes life easy for myself, usually a 1 or a negative 1 if those haven't already appeared in the intercepts. So I'm going to let x equal 1. So now I'm solving 2 times 1 plus y equals a negative 3, or 2 plus y is negative 3. Subtracting 2 from both sides, I find that y equals a negative 5, giving me the point 1, negative 5. So when I plot these on my graph, your paper is oriented a little differently. Since I'm in landscape view, I had to put the graph for 5 over here on this side. So the point 0, negative 3 is going to be right here on my graph. The point negative 3/2, 0. My y is at 0. I'm headed negative 3/2 this way. Well, here's negative 1 and negative 2. So negative 3/2 is going to fall halfway in between those two. And then my final point is when x is equal to 1, y is equal to a negative 5. So down here. And it does look like those points are going to connect in a straight line. So I just put my really fancy ruler here, my straight piece of paper, and use it to create my line. Meaning that any point that fell along that line, if I put those x and y values back into the equation, they would make a true statement here, where this truly was equal.